Hello everybody. Now that we have familiarized ourselves with what is meant by a quadrilateral or what are quadrilaterals, now we proceed a step further. We will now learn what are parallelograms or what is meant by parallelogram. Now, let us look at the word parallelogram. Parallelogram, in this word I can see that there is the word parallel. So a parallelogram is a quadrilateral in which the opposite sides are parallel. So AB is parallel to CD and AD is parallel to BC. So this is a parallelogram, or I can say that ABCD is a parallelogram. Again, let me define it. A parallelogram is a quadrilateral in which the opposite sides are parallel. Now I'm going to tell you or give some proofs about the properties of parallelograms, which are very important for identifying parallelograms and distinguishing them from other quadrilaterals. First is that prove that in a parallelogram opposite sides are equal, opposite angles are equal, each diagonal bisects the parallelogram. Okay. Now here is a parallelogram ABCD. It is given that we have to prove that the opposite sides are equal, or angle D equals to angle B, angle A equals to angle C. Opposite sides are equal, it means that DC equals to AB, AD equals to BC, opposite angles as I said, and each diagonal bisects the parallelogram, or the diagonal divides it into two equal, bisects the parallelogram means two triangles, bisects the parallelograms. The two triangles are congruent. Now first let us read the given. A parallelogram ABCD in which AC is the diagonal. Now in many mathematics books, the theorem or the proof are given in three other. In this theorem, in this proof, I am just proving it these three altogether, but in many books you will find that these three proofs are done differently, but I am doing it here. In case when it is given that prove that opposite sides are equal or prove that opposite angles are equal, then the diagonal AC is not given. It is only a parallelogram will be given. But in here, as it is written, each diagonal bisects the parallelogram, I have the diagonal AC over here. Or otherwise, I would have to construct AC, the diagonal AC, but there would be a further step, that is writing the construction join AC. But in this case, we will not write that, since it is already given that each diagonal bisects the parallelogram. Okay, so ABCD is a parallelogram, AC is the diagonal. Now let us write the given. A parallelogram ABCD in which AC is the diagonal. Okay. Next is to prove. What we have to prove? Opposite sides are equal, then is opposite angles are equal, and each diagonal bisects, each diagonal bisects the parallelogram. Now I don't have to write the constructions, what we have to construct, because there is nothing to construct in this proof. Let us proceed with the proof. First proof. In triangles ABC and EDC. Why I am doing this? Because I am going to apply congruency of triangles for proving these three. Congruency of triangles. Now we know what is meant by congruency of triangles. We have studied that in earlier classes. So I'm not going into the details about what is congruency. For quadrilaterals, it is necessary that you must know what is meant by congruency of triangles. So in triangles ABC and ADC, let me just start by proving that they are congruent. AC equals to CA, it is common. These two triangles are having AC common. Next is angle CAB equals to angle DCA. Angle CAB equals to angle DCA. Why? Let us think it very clearly. It is because ABCD is a parallelogram. What did I tell you in the definition? That opposite sides are parallel. So AB is parallel to CD. Now let us go back and let us remember what are the properties of parallel lines. when two parallel lines are there and there is a transversal, then the alternate interior angles are equal, or the alternate angles are equal. So now forget about these two, AD and BC. Just imagine there are two parallel lines, DC and AB. Okay, DC and AB are two parallel lines and EC is a transversal. Forget this AC as a diagonal. Just imagine DC and AB and EC. So I can say that AB is parallel to CD is already given because ABCD is a parallelogram, and CA is the transversal. So this angle is equal to this angle, alternate interior angles. Same thing I'm applying in a quadrilateral ABCD, in which this angle is equal to this angle. So angle is CAB equals to angle DCA by alternate angles, interior angles, since AB is parallel to CD. Always write the reason beside whatever you're telling. You must give a reason why are you saying that. Next we have is angle ACB is equal to angle DAC. Same thing, angle DAC equals to angle BCA or ACB, whatever you say. Just make sure that whichever angle you are telling it, that must be in the center. Like ACB is equal to angle BCA, but as we are saying angle C, so angle C is in the center. Okay, again alternate interior angle since AB is parallel to CD. Now I can say that triangle ABC is congruent to triangle ADC by ASA criteria, or angle side angle criteria, which means that this and this and this angle are equal. That is why ASA criteria, angle side angle, which means that first angle between that side, one side, and another angle. It's like this way. If I'm just going to rough diagram like this way, so I can say that triangle ABC is congruent to triangle ADC. Now by the classical definition of congruent triangles, it means that everything is equal. Then I can say that angle B equals to angle D, right? I can say that AB equals to CD and BC equals to AD. Why? CPCT. This means that corresponding parts of congruent triangles. Okay, so angle B equals to angle D. ABCD and CD and AD are equal. So I have got my this one, opposite sides are equal, right? Because they are congruent. Angle B equals to angle D. Similarly, I can say that angle A equals to angle C, because when I will draw a diagonal BD, I can similarly prove that angle A equals to angle D. Angle C, sorry. Angle A equals to angle C also. And next is each diagonal bisects the parallelogram. I can see that this diagonal is dividing the parallelogram into two congruent triangles, or it is bisecting the parallelogram. Similarly, when diagonal DB is joined, I can say that triangle DCB will be congruent to triangle DAB. So each diagonal bisects the parallelogram. Hence, proved. Now, your first proof is finished, and from this we learn that the opposite sides are equal in a parallelogram, opposite angles are equal in a parallelogram, and each diagonal bisects the parallelogram into two congruent triangles. Alright, it's not written. Here it is not written as two congruent triangles, but bisects the parallelogram. It is meant by that only. Now next, go to the second theorem. Okay. What is the